What is up, you guys? My goal in today's video is to change your perspective on 3D printed parts and tools. How do I plan on doing that, you might ask? I am going to do a durability test on this Subaru EJ oil funnel tool that I designed and 3D printed myself. If you haven't seen the previous video I did with this oil funnel, I'll put a card up in the top right for you to go check out that video. In that video, I did an oil change on my Subaru and demonstrated the many functionalities of this oil funnel tool. If you would like to pick up one of these oil funnels after you see how strong they are, I will put a link to my website in the description below where you can buy one. With that out of the way, let's get started. Oh no, it broke already. Just kidding, it's fine. So for these durability tests, I want to go from least destructive to most destructive. So first things we're going to start with is I'm going to stand on it. So I weigh about 180 pounds. So I'm going to stand on it and we'll see if it can hold my weight. Standing on it this way, you can see both my feet are off the ground. My hands aren't touching anything. So that's a piece of cake, easy. Now let's put it on its side. Both my feet are off the ground. So the result of that test is just some surface scratches from the concrete. If I did that on a towel, it probably wouldn't have done that, but no structural damage, just some little scuffs to the plastic, but it's still intact. So I would say the funnel passed the first test. So for the next test, we're going to do a drop test. So first drop test, I'm just gonna drop it from arm length out. And I think because of the shape of this funnel, it kind of ends to land up on the bottom here, just because that's how it aerodynamically falls. But no damage to the bottom. Now I can drop it from as high as I can reach up. Rebounded about 2 feet there. So yeah, same thing. We see some light scuffing there, but no damage. So we're gonna try dropping this funnel from different heights. We're gonna start with the first level here. Our way up to the higher levels if it survives. So first we're going to drop it from the first floor, which is probably 12 feet. So we just got some chipping on the edge here, but structurally the funnel is still intact and completely functional. So we're going to go up to the next level. Okay, so level 2, it survived. More of the edge is just chipping off, but still structurally sound. A little bit of like roughness at the bottom here at the initial impact spot, but other than that, it's looking good. So now we're gonna go to level 3. Level 3. Level 3, it also survived. We get a little bit more damage on the top here where the initial impact is, but this is still very functional. Also, more chipping around the edges. So it seems like this little 2mm lip here around the edge is mostly just aesthetic. That's the only reason it's there, but it seems to be the weak point. So I think for future prints, I'm going to extend this lip and radius it so it's a little bit more stronger. So hopefully that will prevent this from happening. 3 levels is as high as I can drop it from, and I would say this test was a success. It's still functional, so I would say that's a win. On to the next test. So since that last clip, I've already made an edit to the file, and you can see here now the edge is a radius instead of a square. I am going to do a drop test with the new design, but that will be on a YouTube short, so keep your eye out for that video. So for the next test, we are going to do a more practical test. I'm gonna see how much torque this funnel can handle. It has the oil filter wrench feature on the inside for loosening and tightening the oil filter. So we're gonna see how much torque it can take before it either skips or breaks. In order to test that, I made this contraption here. This contraption is supposed to simulate the filter being on the car. So it's just a plate with a hole in it. And then this is the original oil filter threaded piece. So the oil filter will thread onto here, press up against this plate here, and I can torque it down. It's in the bench vise, so it'll remain stationary. So this will just thread on here, just if you're putting it in a car. And then it tightens up against there. So normally you're supposed to get these hand tight, so that's about as tight as I can get it by hand. So just to show you guys, tight with one hand outside of a car is probably tighter than you can get it inside the car. So we'll show you that this will come off just using a 3/8" drive ratchet. Okay, easy peasy, piece of cake. So we're going to start with 10 foot-pounds. I'm going to torque it down to 10 foot-pounds, and we'll take it off, and then I'm going to torque it down to 20, 30, 40, and we'll keep going until something happens. So we're going to start out with 10. We're going to start out small. There we go. Okay, we can crack it loose. Loose. So this is going to be 20 foot-pounds. Oh, there we go. Something happened. So at 20 foot-pounds, the socket part rounded off. So that seems to be the point of failure, is that little end piece there at 20 foot-pounds. I don't even know if I could take this off by hand, so that's a lot higher than you should have a filter being torqued to. Okay. Yeah, I can get it, but that is definitely a lot tighter than a filter should be. So I think 20 foot-pounds is definitely a reasonable torque that this can handle. I was hoping it could go a little higher, but I am not surprised that the weak point was the square drive. This is something, if you had just a dedicated oil filter wrench, this wouldn't happen, obviously, because they're made of metal. But with a normal oil filter wrench, you don't get the oil filter funnel feature. So that's where this is different from an oil filter wrench. And I showed you it still functions as an oil filter wrench just fine. But when you do go to unnecessary torques, it will strip out. So on to the next test. For the next test, we're going to be testing the grip strength of the filter wrench, as well as the temperature resistance of the material. This funnel is made out of carbon fiber reinforced PETG, which has a glass transition temperature of 80 degrees Celsius or 176 degrees Fahrenheit. And what the glass transition temperature is when the material becomes soft and it loses its structural rigidity. So it's different than the melting point. I don't know how hot the filter gets when it's in an operating car, but what we're gonna do, we're gonna put this onto the filter on the car, start it, bring it up to operating temperature, and see if it still holds on. The filter wrench / filter funnel feature of this tool is so that when this is inside the car and you're unscrewing the oil filter and the oil comes around the edge, it'll go into this crevice here and then get funneled down to the center. If you haven't seen that video, I'll put a card up here. You can go check out that video and see that in action. The reason this needs to hold on good is because you don't want to be down there holding the funnel onto the filter the entire time. So I designed this specifically to hold on very tight. So let me just demonstrate how tight this holds on. I can swing this and it doesn't come off the filter. It's not glued on there. It's just very snug. We're gonna see how that feature holds up when we introduce temperature into the equation. Let's get started on that test. Underneath the car, I did run the car not too long ago, but it didn't get all the way up to operating temperature. So I have this temperature gun here. We'll set it to Fahrenheit. So right now we're at 111 degrees Fahrenheit, 44 degrees Celsius. It'll have no problem hanging on here. This is honestly probably a temperature that would be okay to do an oil change at, just because you want to get a little bit of heat in the oil before you do the oil change so the oil flows better. We have the funnel installed now. We're going to start the car up and see what happens. So I was running the car a little while ago, so you can see the temp gauge is already moved up a little bit, but we're gonna wait till it gets halfway and we'll temp it along the way as well. We're gonna let that get up to temperature and we're gonna check on the funnel and see what temperature the funnel's at and if it's still holding on to the filter. So it's up to 160 and it's still holding on. So the car is almost up to operating temperature. The oil pressure is at 33 psi, so the oil temperature is not all the way high. Usually once it gets warmed up completely, it's at 20. Okay, so we're at 131. It's getting looser, but it's still holding on. Okay, I could still loosen the filter with this. Oil pressure is down to 20. Car's coolant temperature is all the way up, so let's go check on the funnel. All right, let's see what temp it's at. Okay, so we're at 190. That is past the glass transition temperature. It's still holding on. So let's see what happens when I try to, let's see how good it's holding on. Okay, I don't see any deformation. It is soft, but it's still holding its shape. It's looser. You see it's moving, but I think you could still loosen the filter with this. Obviously I don't want to do that, but it's still holding on to there pretty well. Oops, there we go. Okay, yeah, so now it's not holding on. (190) or 87 degrees Celsius, it starts losing its strength and it starts having a hard time staying on the filter. I mean, it's still staying on there, but I did have a couple times where it dropped. Okay, let's see what temperature the actual filter's at. Filter's reading 221. So the inside was likely experiencing higher temperature. I'm gonna take this off and we're gonna let it cool down and we'll see if it gains its strength back. Okay, so the funnel has cooled off slightly. It's back down to 108 degrees Fahrenheit, but the max temp we got the outside of the funnel to was 190 degrees Fahrenheit, which is above the glass transition temperature, and it did soften, but it was still holding on to the filter just fine. I started to turn it and you could feel it get a little bit loose and then it dropped, but as soon as I put it back on, it stayed on there again. So would you be able to still loosen your funnel if the car is warm? Yes, you would. If you leave it on the car on accident, like say you're doing your oil change, you forgot to take it off your filter and you go for a drive, will it stay on? Maybe. Should you be doing that? Probably not, but accidents do happen. So let's say it got a little warm when it was on the car. We let this cool down. We'll see if it still retains its strength. This is the same funnel. See, the threads are still, or the square drive is still stripped out of it. So now it's back on here. We'll see if we can swing it. Okay, so once back to cooler temperatures, it still works again. Still sticks on to the filter just fine. So this thing can handle the temperature, and even if it does get hot to where it does soften, it does return back to its shape and its original functionality. Okay, so if you've seen on my website, all the parts that I print that are supposed to be in the engine bay of the car, I print them with carbon fiber nylon, CF PA6. And that's because the PA6 nylon, it has a much higher temperature resistance than this PETG does. So like these are parts that are in the engine bay. The TGV delete covers, those are on the motor, that little black spot there. So let's see what temperature that's at. 177 Fahrenheit. And this is just idling in my driveway, but these things have been on the car for months and no warping, no cracking, no loosening. PA6 nylon is the best for high temperature situations. Now, you may ask, why didn't I print it out of the PA6 nylon for the funnel if it's gonna be touching a hot filter? The reason being is for a tool, PETG is much better because it's not gonna be prolonged exposure to hot temperatures, but the weak point of PA6 versus PETG is that PA6 tends to be a little bit more brittle than PETG. PETG has a little bit of flex to it. So if you drop this, it won't break. As I showed you earlier, if I did that same thing with a PA6 nylon funnel, it would have shattered because it's a lot stiffer and it doesn't have as much flex. So this being made out of PETG is more important for a tool because a tool is more likely to be dropped than it is to be exposed to hot temperatures. So a lot of designing and printing parts is picking the correct filament, and that's the reason why I chose to print this out of PETG. So far, all the tests we have done with this funnel tool, it's held up pretty well. This wouldn't be a durability test video if we didn't completely destroy it. So we are gonna send out this funnel with dignity using the hydraulic press. Okay, we're touching. Let's see how many we got. 1, 2, 3, 4, 5, 6, 7. Okay, we've pushed the thing back in there. The little snout that points at the bottom is gone now. 6, 7, 8, 9. I hear some cracking. Ooh. 10. That was awesome. That was spectacular. That was way better than I thought it would be. Oh man. So I don't think the video did it justice, but the funnel shot over there, there's pieces over there, there's pieces all right here, there's pieces over there. But let's inspect the damage. So we got a piece here. This is the main piece. We got some here. Another piece here. There's a piece. There's a small piece. Another small piece. Okay, I think that's it. So it broke into several pieces. Looks like the point of failure was around here, and it exploded there once the pressure was high enough. But the first thing we saw was that this piece that normally sticks out, it got pressed flat with the rest. And then once this started compressing, I think it was starting to push out on these edges here and spread this out, and then it exploded. That was pretty cool. So this is the funnel that I used for the drop test. It's the same as the other funnel, but we're gonna crush this one, try to get a wider angle view. So I'm gonna put my glasses on so I don't get anything in my eyeballs. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, oh God, 21, 22, 23. That one was scarier. Okay, so we got a bit more of a spread on there. There's the big piece, some there, some there, some there. Oh, they're gonna came over there. But then we had some that went all the way back here by the workbench. So this one had some force behind it. It definitely took more presses than the previous one. So here are all the pieces from the second explosion. We see similar damage, just a few more pieces. But it looks like the same point of failure. I am thoroughly impressed at how durable this oil funnel is. I'm glad I did this test because it shows me what things can be improved on and what things work. It also gave me the opportunity to demonstrate to the world how strong 3D printed parts and tools can be with the correct design and materials. If you would like to support my small business by purchasing a Subaru oil funnel tool or one of the many other products that I sell on my website, go to swspeedco.com or click the link in the description below. It means the world to me, and I sincerely thank everyone who has watched my channel over the years and purchased products from my website. I hope you enjoyed the video. If you did, please leave a like. If you know of somebody who might like this video, please share it with them. If you have any questions for me, leave them down in the comments below. And if you aren't subscribed, please consider subscribing. As always, thanks for watching, and I'll see you on the next one. Peace.